Hello, everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome. Tonight, we explore LLM routing and the AutoMix approach. Discover how smarter model selection optimizes efficiency, saves costs, and boosts accuracy for language models, delivering better user experiences. So, how does the concept of LLM routing improve efficiency and language model usage compared to using a single, more powerful model for all tasks?
LLM routing is just like having a smart assistant who knows exactly which tool to use for different tasks, instead of just using the biggest and most powerful tool for everything. Imagine you are building a treehouse. For some parts, you need a hammer, while for others, you probably need a saw. If you only have a giant hammer, you might struggle to make precise cuts, and it could take longer to just finish the project in the same way. So LLM routing helps choose the right language model for a specific question or task. This means that instead of using one big model that might be really powerful but not always the best fit, the system can quickly pick a smaller, more specialized model that can do the job better and faster. So this approach not only improves performance but also saves time and costs, making the whole process of using language models so much more efficient.
Could you elaborate on how the LLM cascade kind of strategy functions in practice, particularly how it determines when to escalate a query from a smaller model to a larger one?
So the LLM cascade strategy works like a two-step cooking process. We're making a dish. Just imagine you are trying to make a soup. First, you start with a simple recipe that uses basic ingredients. You taste the soup just to see if it's good enough. If you think it tastes great, you just serve it right away. But if it doesn't taste right or is missing something, you then decide to just add more ingredients and make it fancier. In the context of LLM cascade, so the process begins by sending a query to a smaller, less expensive language model. This model generates a kind of response. After that, it checks its own answer to see if it did a really good job. If the small model believes its answer is correct, that answer is actually sent back to the user. However, if it thinks the answer isn't good enough, the query is passed to a larger, more powerful model that can provide a better response. This strategy is so efficient because it starts with a quick and cheaper option. Only when necessary does it escalate to a more expensive model, which really saves time and resources. The clever part is that the small model's self-evaluation acts like a taste test, helping to decide whether to stick with the first answer or to upgrade to a more complex solution.
What are the limitations of the LLM cascade approach, particularly regarding the self-evaluation process of smaller models? And so how does the AutoMix approach address these challenges?
The LLM cascade approach has a pretty significant limitation when it comes to the self-evaluation process of smaller models. Think of it like a student grading their own kind of test. If the student is overly confident and thinks they did so well when they actually didn't, they might not ask for help or try harder. This can lead to poor answers being given to users because the small model might incorrectly judge its own response as good enough when it isn't. So to tackle this challenge, the AutoMix approach introduces a more sophisticated way of evaluating the small models like self-assessment. It uses something called a partially observable Markov decision process, which is a really fancy way of saying it looks at past data to better understand how accurate the whole self-evaluations might be. So imagine having a teacher who knows how well students usually perform based on their past tests. This teacher can help the student realize when they might need to just double-check their answers instead of just trusting their first instinct. By incorporating this method, AutoMix actually helps improve the decision-making process. It reduces the chances of the small model making a poor self-evaluation, which leads to better overall answers and a higher quality of final output for users.
So, can you explain how the use of high temperature settings during self-evaluation in the AutoMix approach contributes to creating a probability distribution of accuracy and why this is so important for routing decisions like?
Using high temperature settings during self-evaluation in the AutoMix approach is like turning up the heat when cooking to create a more flavorful dish. So when the temperature is high, the language model's responses become more varied and unpredictable, which allows it to explore different possibilities rather than just sticking to safe, expected answers. By asking the model to self-evaluate multiple times at this high temperature, So it generates a range of responses. This variety really helps create a probability distribution of accuracy. Think of it like throwing a bunch of darts at like a target and seeing where they land. Some might hit the bullseye, while others might be just off the mark. By looking at all these attempts, we can understand how likely it is that the model's answer is actually correct. This probability distribution is important for routing decisions because it provides a more nuanced view of the model's performance. So instead of just getting a simple yes or no answer about whether the response was really good, we gain insight into how confident we can be about that answer. If the model shows a high probability of being correct, we can confidently use its response. Like, if the probability is low, we know it might be better to consult a larger model for a more accurate answer. So this approach helps improve the overall quality of responses and makes routing decisions smarter and more reliable.
So what are the potential implications of implementing the AutoMix approach in real-world applications, particularly regarding cost-effectiveness and user experience?
Implementing the AutoMix approach in real-world applications can have significant implications for both cost-effectiveness and user experience. So, first, regarding cost-effectiveness, AutoMix allows organizations to build an efficient language model routing system with very little data. Imagine being able to set up a whole bakery with just a few basic ingredients. This means businesses don't need to invest heavily in large data sets for expensive models right away. So they can start small, using only a handful of examples to create a functional system. This can lead to substantial savings, as it can avoid the costs associated with maintaining larger models unless absolutely necessary, in terms of user experience. So the AutoMix approach can enhance the quality of interactions. By using a probabilistic method to evaluate responses, it ensures that users receive more kind of accurate answers. It's like having a helpful librarian who not only finds books, but also knows which ones are most likely to have the information you need based on past experiences. This leads to quicker, more relevant responses, making users feel understood and valued. So overall, the AutoMix approach can create a more efficient, user-friendly system that balances performance and cost, leading to better outcomes for both businesses and their users.
How does the AutoMix approach compare to other existing methods for language model selection in terms of flexibility and adaptability to various query types?
The AutoMix approach stands out in terms of flexibility and adaptability compared to other kind of existing methods for language model selection. Imagine you have a versatile toolbox. Some tools are great for specific jobs, while others are just more general and can handle a variety of tasks. AutoMix allows you to choose the right tool based on the specific needs of each query, so using a method that adapts to different types of questions, while other methods like Route focus heavily on analyzing the query itself and rely on a lot of data to make decisions. So AutoMix uses a lighter approach with the Bradley-Terry model. So this model really weighs the relevance of past examples to determine the best model to use for a given query. So this means that AutoMix can quickly adapt to various query types without needing extensive data for every situation. In contrast, methods that depend on large data sets and embeddings may be less flexible, as they require more upfront information and might struggle with new or unique queries. AutoMix's ability to function effectively with minimal data makes it more adaptable, allowing it to respond to a wider range of questions more efficiently. So this flexibility can lead to better performance across different contexts and user needs.
So thank you all for tuning in today. It's always been a truly insightful conversation exploring the fascinating world of language model efficiency. So we delved into how LLM routing is revolutionizing the way we approach complex tasks, emphasizing the power of choosing the right specialized model for the job, rather than relying on a single massive one. So this concept, particularly the LLM cascade strategy, starts with a smaller model and only escalates to a larger one when absolutely necessary, significantly boosting resource efficiency. However, we also discussed the inherent challenge, the limitations of a smaller models like self-evaluation. This is precisely where AutoMix really emerges as a game changer. By leveraging a more advanced evaluation method that intelligently uses past data and high temperature settings, AutoMix creates a robust probability distribution of accuracy, enabling much smarter reading decisions. So, the implications of implementing AutoMix are pretty clear. It promises substantial cost savings, delivers a remarkably improved user experience through more accurate responses, and offers unparalleled flexibility. Its ability to adapt to diverse query types without requiring extensive new data, so truly sets it apart from conventional methods. Ultimately, AutoMix stands out as a superior, more efficient, cost-effective, and profoundly user-friendly solution for language model routing. So, we appreciate you joining us for this deep dive. So, until next time.